Welcome students to Vignan Institute of Engineering for Women. Myself Sailaja, Assistant Professor of CSC Department in Vignan Institute of Engineering for Women. Today I want to teach a topic on DES algorithm, which is in cryptography and network security. So actually cryptography means if you want to store any data in the database, or if you want to transfer data from one user to other user, the data should be in a secure manner. So if you want to transfer the data in a secure manner, we should follow some cryptographic technologies or methodologies or algorithms. Okay, so today my topic is DES algorithm. The agenda of this DES algorithm is, the first one is introduction to DES algorithm, the second one is structure of DES, and the third one in how the round key generation is going on in DES algorithm. Next one is crystal cipher structure, encryption process, advantages of DES algorithm. So what the student will get from these topics, the outcome of this DES algorithm is can easily encrypt and decrypt the data with a single shared key. Means in the cryptography we have two types of security algorithms. One is symmetric algorithms, another one is asymmetric algorithms. So what is actually DES? Is it is a symmetric or asymmetric algorithm? The first one is the DES is a data encryption standard. Algorithm is a symmetric key. What is a symmetric key? Actually in the symmetric key, the data can be transferred from one user to another user within a secure manner by using a single key. Single key means here the single key is using for encryption as well as decryption of data. So actually it is also a block cipher algorithm which is created in IBM team by the NIST. So this algorithm takes plain text of 64 bits of blocks of data and converts the 64 into a 64-bit block of data into a cipher text. Actually it will take a 64-bit plain text, and this plain text is here the input is a 64-bit plain text, and the one more input is given to this DES algorithm is 56-bit key. So why we take this 50-bit key for this DES algorithm? Because if you want to encrypt the 64-bit plain text, we should encrypt the data by using this key. So by using this key we can decrypt the data or encrypt the data into a cipher text or plain text. So actually this is the block cipher. Block cipher means we can transfer the block of data at a time, but in a stream cipher we can send a single character into a storage, or we can send a data to the other person. So here, so this is the actual structure of DES algorithm. In this DES algorithm, the first one is 64-bit plain text. It is take as the input of DES algorithm, and one more input is this is 56-bit key. Okay, so this 56-bit key is sent to a round key generation. This is a technique which can send the key by a reducible key size. So how it is possible? It is seen in the next slide. Okay, so first one is whatever the input we are given to the DES algorithm, it takes as the initial permutation. So then we can follow from this initial permutation, the whatever the output get from this initial permutation, it is sent to other blocks. Actually in DES algorithm we have 16 rounds for encryption and decryption the data. After that encryption and decrypt the data, the final output is sent to the final permutations, which is given as a 64-bit cipher text. Okay. So here DES algorithms text whatever the input we are given to DES, the first step is the process begins with 64-bit text. Means here we take a plain text of 64-bit data, then it is sent as the initial permutations. Means the 64 is sent to initial permutation. This initial permutations is divided into the 64s into two halves. One is left plain text, another one is right plain text. Each plain text contains 32 32-bit of data. So this left plain text data will contain 32-bit data, and at the same time right plain text will also contain the 32-bit data. After this dividing into two halves, it's sent to the 16 rounds. In each round we are encrypt the data, and finally the encrypted data is sent to the final permutations. These final permutations will combine all these things and produce as a cipher text. So the next initial permutation, so now only we said that this initial permutation is divided into two halves. One is LPT and the other one is RPT. So each LPT goes through 16 rounds, means here we have a 16 rounds of encryption process, each round having some XOR operation as well as S-box operation, P-box operations. What is that we will see in the next slide. So next, finally the LPT and RPT are rejoined, means in this final permutations the LPT as well as the RPT encrypt the data and will rejoin in the final permutations. And finally what we get from this, we can get the cipher result of the actually plain text. See, in the previous slide we are seeing, in the previous slide here, round key generation. What is this round key generation? How the key is affected in this circuit? First of all, we are taking 64-bit key. Actually what we said in the DES, we take two inputs. One is for 64 plain text and another one is 56-bit key, but here we are given 64 bits. Why we given? Actually our plain text is 64, means your encrypted, means cipher text is also 64 bits. But to encrypt or decrypt the data, here we are using plus key. Key is also taken, first of all we take as it is a 64-bit, but this 64-bit is given to the parity drop. So actually this is circuit is actually the working of this round key generation, how the round key generation is going on. So the parity drop, here this parity drop will eliminate totally 8 bits in the 64-bit. How it eliminates 8 bits in the 64 bits? See here. See, this 64-bit original key, means here 8 into 8 matrix. It is arranged the 64-bit key into 8 into 8 matrix. In that last column is there, na? In this last column the bits, what are the bits are there? Here 26, 60, 41, 8, 52, 25, 36, 19. These all 8 bits are eliminated and it is transferred to the, it is a 64-bit, but it is eliminated this all particular column. Then we will get here 64 element 58 bit key, 56 key. So this 56, take it as a 56 bit is a resulting key. Okay, so then this 56 bits, whatever the 56 bits we are eliminating the parity bit, this 56 is again divided into two halves. One is 28 bit, another one is 28 bit. So this 228 is take it as an input to this compression P box. What the compression P box will do? So it is so actually this compression P box will give a data of what is this, 28 plus 28, it will get as a 56 bit actually data. But in this compression data is this is given to the shift left and shift right. It means here it is divided into this 48-bit key is given to the round key 1, and this round key 1 is after this round 1 generation. So the encryption process is further broken down into 5 steps. One is key transformation, next one is expansion permutations, next one is S-block permutation, P-block permutation, XOR and swap. So what is going on this key transformation? In key transformation technique, here the keys are reduced into 64-bit to 56-bit. In this expansion permutation, what is going on? See, in this expansion permutations, actually we take 32-bit RPT, 32-bit RPT of IP. IP means it is an initial permutation. In initial permutation, we take 64-bit of data into two halves. One is 32-bit, another one is 32-bit. So the 32-bit of RPT of IP is expanded to 48. Why we expanded to 48? Because here we take it as the input key has a 48 bits. So the expansion is from 32-bit is divided into 8 blocks of each 4 bits. Okay, the 32 block is divided into 4 bits, 4 bits, 4 bits up to 4 8 bits. Okay, here 4 8 bits. See how it is expanded by grouping it into a 6 bits. This 4 bits is grouping into a 6 bits in this manner. See 1 2 3 4 whatever the bits are, they are taken in this one, bit 1 bit 2 bit 3 bit 4 position, we will drop like this 1 2 3 4. So how we get this first bit and how we get this 6th bit? So in this first bit, the next 4 bits in the first position bit, whatever the bit is there in the first position in the next bit, so it transferred as the 6th bit, and whatever the last bit of 8th bit, this is the 8th block. In the 8th block, whatever the last block is there, it is transferred to act as the first bit. So like this, these 4 bits are expanded into a 6 bits. So in the second, as in the second process is also same. See here, this 5, 6, 7, 8 blocks are transferred like this, and this 6th, 7th and 12th are the whatever the last bit in the previous bit is transferred to the 7th bit, and whatever the first bit in the next block is transferred as a 6th block. Like this, the 32 bits are expanded into 48 bit data. Okay. So in the expansion permutation, like this, 32-bit RPT text is converted into 48-bit data. So next one is, after expand permutation, the next one is S-box substitution. In S-box substitutions, we are taking 48-bit data. So this 48-bit is again divided into 6 blocks, 6 blocks, 6 blocks subdata. So this 6 block subdata is take it as an input to the S-box, and this S-box is again converted into 4-bit block. In S-box substitution, the 48-bit RPT text is divided into each 6 blocks information, like this 6 block data. Totally we get 8 6 block data. So this 8 6 block data is given as an input to the S-box, and the output of the S-box is 4-bit output. So how the 6-bit is changed into a 4-bit data? See the process of S-box working here. So here it is a 6 bits data information. Each block contains here 6 bits of information. In that 6 bits, the first bit and the last bit, take it as a row data. Means here, see, these are the rows, and here these are the columns. Okay, so in this, the first bit B1 and the last bit 6th bit B6 is choose in this row. Means here the bit is here 0, and here the bit is 1. So in the row side we can see 0 1 combination. So here it is the 0 1 combination. So take here 1 1 0 1. So in the column wise, you can see the value 1101, where it is. So 1101 means here. So you can see the information how this 6-bit data is changed into 4-bit. So here 01 plus 1101. What is the data here? So this is the actual data. Means here the 4-bit data is 1001. So like this, the S-box 6-bit data is converted into 4-bit data. So the next one is, so this is the P-box permutations. In S-box substitution, what we did, so the 6-bit information is converted into a 4-bit data. So here what happened, the P-box permutations, output of this S-box is given to the input to your P-box. So in this P-box, actually we have 32 bit is permuted with 16 to 16 permutations. Means here actually we have 32 bit of information is there in your P box, that is arranged like this. So here 32, sorry, 1, 2, 3, 4, up to 16, and here is also 16. So like this, the table in the P box is arranged, depends upon your S box output. After that, what is happening is, see, it is the entire encryption technology, which is today we discuss about the topic of DES algorithm. So in this, whatever we have taken, the first it will take the input has a 64-bit plain text. This 64-bit plain text is divided into two halves. One is 32-bit LPT and the other one is 32-bit RPT. So, but the main operations in DES algorithm is done in this 32-bit RPT, means write plain text. So, in the write plain text, we are performing the following operation. One is key transformation technique, the another one is expansion permutation, next one is S box and P box. After final all these things, we can get the whatever the data we are getting, that the data is in the form of 32-bit information. Okay, this 32-bit information of encrypted 32-bit RPT data and the 32-bit LPT data both will XOR. XOR means we will do the XOR operation, this 32-bit with this 32-bit, means here the RPT encrypted 32-bit is XOR with the 32-bit LPT data. So finally what the output we get after XOR operation, that is stored in this 32-bit RPT text. Okay, how you will get this 32-bit LPT text? It is from this 32-bit RPT is directly we take it as the 32-bit LPT here, means just we are exchanging the data bits. Okay, so after that actually it is going on. So we take as an input for plain text and it is given to a initial permutation. What is going on in initial permutation? The initial permutation is divide the text into two halves. One is LPT, the other one is RPT. These both are take it as an input to the 16 rounds encryption process. After the encryption process, we are applying so many techniques like key transformation, expansion permutation, S box and P box. After all these techniques, we get the finally encrypted data with the 32-bit from the RPT side and the 32-bit from LPT side. Both will combine by this final permutations. These final permutations will combine the both are 32 bits and it will produce a 64-bit cipher text. This cipher text is the encrypted data. So the advantages of DES algorithm is it is very useful for large amount of data is required to transfer from any application. So and it is also compared to software, it works faster in your hardware systems, and triple DES is used 168-bit key, which is hard to crack the data. So why we use this DES algorithm is, if you want to send any information to other persons, we have to provide some secure, because it is a confidential data, means we provide some security to your data. So to give a security to your data, we are decrypt the data we are encrypt the data whatever we send to the user. So these are the actually this DES is very useful when we transfer a large amount of data to someone. And also it is in DES we have so many standards are there. One of this is triple DES follows 168-bit data. Actually this DES follows a Fistel cipher structure. We are studying the previous lecture. So why this Fistel cipher is very important means, once we go for the previous slide, why this Fistel structure is useful. See here, DES follow the main structure of the 16 rounds follow this type of structure. So this structure is called a Fistel cipher structure. In this Fistel cipher structure, so whatever the text we are taken as input, this is divided as the actually we study now in the DES, the data is the bits are divided into two partitions. Like this in Fistel structure also the data is taken into two parts, one is the left side and the right side, so equally share. So whatever the right text is there, it is taken as a f function, means what is going on this f function. In this f functions, whatever the key is produced to your data, that key is interact with this data bits in the right plain text and will be generated generate some text. The text is the output of that f function will XOR with this LPT text. It will give the actually RE text, means here write plain text. So the DES follows this type of structure. So and it is very in the 16 rounds we follow the same structure, but in the last round whatever the output we get, that output is directly we take it as a final permutations and produce as the cipher text. So this is about DES algorithm. So thank you. Next class we will discuss about AES algorithm.